Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In last lecture we have discussed about something very important about the behavioral research approach and different methods by which we can capture the human behavior and we can establish certain sort of relationship in built form, and also like we can improve the overall user experience through such kind of design where people behaviors are captured in terms of their preferences, in terms of their perception, and that can be done through different way. So during that discussion I've also mentioned very briefly about a technique called simulation. Now, through simulation, definitely we can create different scenario, hypothetical scenario. We can present those scenario before the respondent or the participants, and we can get their view on that. Maybe it is just a project of urban design level where different sidewalk, street that are redesigned to visualize that what could be the possible changes that people they experience, and then accordingly we can take their feedback and improve the design. Or it may be just, you can say, city level, like disaster mitigation map, or maybe it is something like we would like to know that for certain unprecedented rainfall, that what could be the scenario, what are the areas that are vulnerable. So this kind of flood mapping can also be possible through simulation. Now with that, today we'll be discussing exactly on simulation. Today we are at lecture number 56, titled Simulation Based Studies in Planning and Architecture. In this whole lecture, what we are going to learn, basically we'll understand what is simulation, and also we'll discuss about the advantages of simulation, applying simulation as a research method. Then we'll discuss something on simulation in the architectural field, architectural research, and also we'll discuss the application of simulation in planning research. Along with that, we also discuss different challenges in simulation based research, and also like at the age of AI ML, we'll also discuss about the future trend in simulation research, and finally we'll summarize our understanding of this lecture. Now defining simulation. So if we go with some dictionary meaning, say for dictionary.com, it says the simulation is an imitation or enactment of something that is anticipated or being tested. Where we look at the Oxford Dictionary definition, simulation is a situation where a set of condition is created artificially to study or experience something that could exist in reality. So that is almost like creating the real environment but in an artificial way. And it is important because many a times when you think about a mega infrastructure or mega project, that requires time, cost, and also the land. Say for example, without taking any certain user behavior or user requirement, if we implement such mega infrastructure, and then after all, like it is not being used by the users, so it is wastage of time, resources, and also definitely the land. So for that, if we can get first hand confidence from the users that okay, this kind of environment is going to come, do you have any such observations, any such feedback which can improve the scenario, it's always better. So in simulation exactly we do the same thing. We create the situation where set of conditions is created artificially. It may be like giving a built environment, or it may be something that based on data we do the simulation for a traffic network, or it can be a flood simulation as I already mentioned. It can be a building performance simulation, that depending on the orientation of the building, how you can plan your overall like heating and ventilation. Okay, So this kind of building envelope analysis and other part of thermal analysis of a building and orientation of the building, so those are different application in architectural field of simulation. Now coming to the another dictionary, Cambridge dictionary definition, it is a model of real activity but created for training purpose or to solve a problem before it occurs in real life. So real life experiment, the real life object is something, and here you are creating the scenario look alike of real environment, but it is not. By simulation we can experiment all those future scenario and take the input from the users, or you change certain parameters and try to see what are the changes that are possible before actually implementing on field. So there are so much of advantages of using simulation, but also we'll discuss that there are certain limitations, because to have a good simulation you also need some sort of base data, because you have to train your model that if this is the input, this is the output, and then it can replicate, it can scale up the model, it can perform in different way depending on the simulation software, depending on different sort of input and output. So always for all simulation we use a term called MOP, measure of performance, that how it is performing, how much it is predicting like actual or accurate. So there should be some sort of validation for the simulation result, otherwise you can just simulate anything and can give some impractical scenario which is not possible in real scenario. So that is why it is very important to the researcher, like to select a proper simulation tool and how to use it effectively, because unintentional use or a wrong use of a simulation can lead to a wrong decision making. So we have to careful on it. Coming to the advantages of simulation, it helps in informed decision making. Using simulation results for better planning and design choices. Now it is something nowadays, like you have those kind of options available. Even you go to purchase a cloth or maybe a spec, you want to go for a, like you think that you want to purchase a sunglass. So now in current scenario you have those kind of simulated environment where your face will be detected, you can change different glasses, maybe the shape and color, and you can just see yourself like by wearing that kind of devices or the sunglasses how you look like, and based on that you take a call that okay, this is probably the best one. So this is just one simple example that I'm giving. Similarly, whenever you design different buildings, so each building will have different sort of outcomes. Somewhere the circulation is optimized, somewhere probably this particular facade is exposed to the sunlight. Depending on the client's requirement, depending on the location, depending on the sun path, so many parameters if you take into consideration and build certain simulation, you can show the various options possible with all these criteria to be fulfilled. And after all, like the client will select the best design suited for him or her. It will also help in cost reduction, because always if you want to tweak some of the options and recreate a new built environment, it is doable through simulation. But if it is, say for example, it is made on ground and then you express that okay, something is missing, probably it is like very tough to manage, or else it is very much cost intensive. Where the simulation, if you apply, it can also minimize the expensive design iteration and modifications, because base model is ready, then you can just tweak it. May be changing the color, it may be changing the texture, or it may be certain parameters which can give different set of output. Simulation also helps in the way of like the innovation catalyst, encouraging experimentation and fostering creative solutions. Now, whenever you have certain constraint in a physical modeling or experiment, simulation can overcome that obstruction, or maybe you can say the bottleneck, because in that particular case you can alter, you can see some sort of advanced options, which probably, if you don't have the option, you just restrict yourself to the limited alternatives. But here you can come up with certain interesting and creative solutions. It also provides some sort of improved outcomes, assured improved outcomes, enhancing project efficiency and achieving better performance, as because you have those control parameters with you. If you see that size of the window has to be changed, if the material of the window has to be changed, if the orientation is like little bit, you have to think certain sort of shading devices to be added for lowering down the heating on some of the southwest of the wall in such kind of climate. So those kind of changes you can very quickly do in simulation. Obviously you should understand the software. If you need to understand all these basic parameters, then only you can able to make those decisions to come up with a better improved outcomes. Now coming to the architectural simulation, broadly when you see, it can be visual simulation, it can be related to the daylighting simulation, where daylight optimization is something that we always talk about, that how to utilize it. At the same time, it will not disturb the internal environment, the indoor environment, but it can also improve the efficiency of the lighting of the building. Building near coastal region, or maybe in some places where wind is very much to be taken into consideration as a live load, or maybe especially for the tall structure, skyscraper, this is very important, because with increase in height of the building, the wind pressure will also increase in those places. So for that, what kind of aerodynamic shape that we require to reduce the wind pressure on those kind of tall structures, that can also be simulated. Thermal comfort assessment is another one, where you can also do some simulation, the ambient quality, ambient environment, which can give the best comfort. It can be like something like acoustic analysis, that can be also simulated. It can be some energy modeling and analysis. These are very few. You can keep on listing all those. Probably you will end up with say 100, 200 such kind of application, or the areas where we can apply the simulation as research method. Now coming to the first pointer, that is about visual simulation, that probably those who are architect or already practicing or teaching architecture, they can very well relate with this 3D modeling for preview of building aesthetics. Now definitely earlier we used to make the physical model and we just try to experience it, but now in current days, with all these advanced graphic software, we can create hyper realistic images, some high resolution real look like animations, through which we can make certain walkthrough, we can get experience of the space through this virtual environment. In today's life, we are talking about so much on this virtual reality and augmented reality, by which it can leverage on the understanding of those kind of design and planning very effectively. With this help of metaverse and all, you can experience and you can also alter the things, you can suggest the thing, you can make certain changes in the design based on your requirement with the joystick and other equipments, which can give you a sense of ownership of the space as well. And also it can give the designer or planner better confidence that okay, you have experience and now you are giving feedback based on that, apart from just typical drawing like plan elevation section, that is something that we prepare. So this is something that now in today's time it is very much popular in the field of architecture, and people are using it even whenever we talk about those kind of parametric design and all. So it's all about some sort of simulation that we use. Now coming to the daylight simulation, there are software available which actually help to understand the sun path movement, the location of the building, and the relationship between the location, orientation of the building and the sun path. In this case, it is helping in analyzing natural light distribution for optimal interior lighting through solar radiation studies and sun hours. It also helped in shadow analysis, because some of the area, suppose not only the area which will get exposure to the sunlight, but the area which are under shade, that can also be used effectively for sitting place or maybe for certain vegetation. So this kind of simulation can help you out about that. Here you can see under different heights, under different time, how this shadow analysis can help to demark those areas. Like if you want to make a pathway, if you want to make a sitting place in a office building surroundings, so in such cases you can obviously do the simulation, and then accordingly you can change the massing, the solid, the opaque part of the building, or maybe the transparent part of the building, that we can do. For daylighting simulation, it is very effectively used. I talked about the wind as a factor. So wind analysis is also very important, and for that we do all those testing like the tunnel effect and all. So building orientation for proper ventilation and assessment of wind loads on building. So in these cases, like through the software we just test the different wind direction, the prevailing wind direction, or maybe in case of certain a storm, or maybe it is expected like prevailing wind direction that there will be some sort of wind blow at certain kilometer per hour. So what will be the reaction to the building? It will also depend on the shape and size of the building. As I already mentioned that for high rise building it is very important. Now whenever you have something like just perpendicular to the wind direction, so that will create some sort of pressure on the surface. So for such kind of reason we also try to change the shape, the orientation of the building, or the shape, overall shape of the building, to give some sort of aerodynamic shape, the way like we design all this bullet train or maybe the aeroplane. So there is some sort of aerodynamics coming into that discussion and consideration, where the wind can very easily flow, okay, and it will not create the pressure. So here you can see for this particular building that for this particular surface this is the wind direction and it is creating so much of pressure, where this is the external simulation of Oppo headquarter designed by famous architect Zaha Hadid architects, and here you can see that how the airflow around the building are simulated. So for this kind of profiling or building, it is actually reducing the wind pressure and can sustain better. So the application of the simulation is actually helping to determine the overall shape of the building. Now accordingly you can change the parameters, you can change what kind of structural system that you are going to adopt, whether you go for bracing, whether you go for some kind of outrigger structure, or it can be interior structure, exterior structure, or combination, whether you go for a core, single core or split core. So those kind of structural system that can be determined based on this analysis. Now coming to the thermal comfort assessment, so evaluating indoor climate and occupant comfort, and also in those cases like definitely it will depend on the orientation of the building, the internal fixture, that how many lights that you have, how many fixture like computers that you have, because all will emit some sort of energy and there are certain radiation. So through that, how the body will adjust. So in those cases you can find that there are certain relationship wherever there is a proper ventilation, so you have certain sort of body comfort. Wherever it is like choked, you don't have much kind of ventilation, then you can have a different feeling. So this kind of simulation can also be performed, and accordingly you can change the decision on the type of materials, because their thermal conductivity is different, or you can go for larger opening or smaller opening as and when required. Even with the artificial ventilation, okay, or maybe heating ventilation system, so with that also you can compare the different kind of setup, and then accordingly you take the final call on what kind of design is required. Now coming to the acoustic simulation, especially for the auditorium or maybe like the studio or some kind of concert hall. So for such kind of cases, acoustic is very important to retain the quality of the voice, so that you can enjoy the performance. There should not be much kind of decay, or maybe there are echo. So for such kind of cases also you can have certain sort of simulation which will be ensuring the optimal acoustical performance in each design space, analyzing sound intensity and vibration based on the material. So here you can also check, uh, depending on different materials that you put on ceiling or the wall, and then the sound absorption coefficient, all those parameters you can simulate, and then try to finalize that what kind of shape of the auditorium or what kind of material that can give a better feeling. Now energy modeling and analysis is something where you again talk about the orientation of the building, and also like you talk about the operational energy of the building. So evaluating building energy consumption in lighting, HVAC, refrigeration, plug loads, water heating and other mechanical and electrical components. So it's because like if you talk about the overall energy consumption, any building will have two parts. One is the embodied energy, which leads with the material, and other part during that particular cost of making it. During construction will the embodied energy part, but normally we just take care of the operational energy, like for lighting, artificial lighting, ventilation, then you have some plug load, you have certain sort of heating if required, if it is the building uh, somewhere in cold climate, so there might be a centralized heating system. So for all these artificial mechanical and electrical appliances, how the building is performing, so whatever the total energy that you are consuming, and then the proportion that okay, maximum in HVAC or minimum in lighting, that can you simulate, and then according to that you can change some of the design parameters. Like maybe in some areas where you can get that this wall is getting heated, you can think about some material which is protecting that radiation, or you can think about some kind of cavity wall which can also maintain the indoor and outdoor temperature effectively. So those kind of design interventions can also be taken out of this architectural simulation. Now coming to the planning simulation and application of simulation in planning, it is equally important, and there are certain sort of applications. Say for example, urban growth simulation, network flow analysis in infrastructure system, zoning impact assessment, and disaster preparedness. So let us understand. Now urban growth simulation is something where you perform certain sort of simulation and apply some special method by which you can do some land use land cover LULC analysis and predict the spatial growth pattern, that analyzing the trend and also what would be the future direction of growth. Mathematical models are established to predict urban system functions, like it can be urban system dynamics modeling, where you perform the simulation, what will be the growth in population, what will be the growth in vegetation, what will be the reduction in the water body if the same trend will continue. Like that, here you can also see that this is some kind of representation of this particular city, where from 1989 to 2024 the change in the land use and land cover, and you can very clearly see that built up, which is represented by red color, that is very much predominant in 2024 compared to that of 1989. And subsequently there are reductions, some of the green patches are still there. It may be like the protected area or maybe low development area. So this is something is giving you that okay, the city is also reaching to a total built form, and the ratio between built and non-built or the green is reducing day by day, which is also against the nature. So there are issues with those kind of local environment, because vegetation is not only helping you to improve just the beautification, but it also helps in some sort of balance, the oxygen balance, or maybe some cases like the properly arranged, properly implemented green areas can also reduce the pollution in large. So it has multiple benefits of having the vegetation and all. But yes, through simulation, if we talk about the current context, so through simulation you can observe that what is the scenario and how it is going to change in future. Coming to the network flow analysis in infrastructure system, here maybe modeling the traffic flow, municipal water distribution system that you can map. So there are n number of softwares available. So PTB VSIM is one of that, which can help you out for the traffic simulation. You can create the realistic environment, you can give those input like the vehicle composition, different sort of traffic that you observe in different hours, and then it can help you to simulate that whether your current infrastructure is capable of accommodating that many cars, whether there are conflicting points or there are certain sort of critical points where there might be some sort of issues and there will be some sort of bottleneck, and the traffic can get choked and there might be some issues with the accident. So through simulation you can get and you can solve it. So it is something like you create 3 lanes, and if you see the performance is not good in intersection, there are some undesirable delay for the traffic, so that can lead to some of the decision making. Either you change the vehicle composition, in like you can increase more public transport and you reduce the use of private transport in that way, which can help, or else you augment another lane to solve it out. Now another application in planning simulation is the zoning impact assessment. So predicting impact of different zoning regulatory strategies on urban growth pattern. So in this particular case, definitely whenever you think about okay, uh, giving more residential area, or maybe you just think about you go for a medium density development or mixed land use development, what could be the scenario and all. So this is something very useful to also see the future scenario. There are certain changes in many cities now, they're going towards the mixed land use for certain advantages, or maybe you don't need to travel for a longer distance because most of the amenities are within your proximity, or maybe in the downstairs you will get it like all these basic amenities and utilities. So for such kind of cases you can also do the zoning impact assessment through simulation. Now this is very important and interesting slide, where through simulation you can also see the possible disaster that may happen due to certain sort of natural calamity. Disaster preparedness is something that where we can apply the simulation. It is simulating the worst case scenarios for disaster preparedness. So in this case, here we are just doing in this particular image, you can see that urban flood simulation, that if there are certain water bodies if there will be some sort of rain, and then depending on the rain intensity and the duration, that what could be the possible area of the flooding. So here you can see some of the settlement, they are under threat because they are in the low lying area. So like that you can create those scenario, and then accordingly you can make certain kind of mitigation plan. You can be well prepared that okay, if that situation arises, so at least those locations you need to evacuate faster. So once you get that kind of warning that okay, there will be a heavy rain, there is a possibility of a cloud burst, or maybe there are certain sort of cyclone will heavy rain, so you can alert people. This is one way. Or else you can create the enough infrastructure to redirect those kind of flow of water. Now there are few challenges in simulation based research in architecture and planning. The data accuracy, obtaining reliable and comprehensive data for simulation model is very important, because we have to understand it is a system generated solution. So if you give any input, it will give you the output, but how to interpret it, that is very important. If you able to give proper data, if you can able to train your model effectively, so it can replicate almost the real scenario. Otherwise it is always having some sort of issue. So you need data very accurate and reliable. Computational resources, addressing a high computational power and time requirements. So I have shown you some of those kind of simulations, some results, some sort of output of those softwares, but it needs high computational system. It requires certain sort of GPUs. So for such kind of thing, you need some money, because with our normal computer maybe that software will not run, or even if it will run, it will take more time. And whenever you think about the scale, if you want to make a simulation for a city, you require that kind of heavy computational thing. But if you want to do it just for a particular office room, probably you don't require that much. So depending on the scale, depending on the type of analysis that you are going to perform through simulation, it will require certain sort of computational resources. This is a question on model validation. Ensuring simulation align with real world scenario. So real world scenario and then the simulated scenario, where is the match? So for that you may need to test some of the pilot thing, those strategy, and then you need to compare. Once you validate the simulation based result, which is like also in real world experiment you are getting the similar output, then only you can make that model or declare that model reliable. Complexity and expertise, gaining specialized knowledge for simulation software and methodologies. That's why I say that apparently it looks that okay, we can create different scenario, but it needs expertise, it needs time, because interpretation of the simulation result is also very important, and also how you provide the input to the simulation model. So based on that, definitely the result will vary. Coming to the best practices in simulation based research, the validation and calibration, so ensuring model accurately represent the real world conditions. Sensitivity analysis, evaluating model responses to variation in inputs. So how sensitive your model is, that you change one parameter. Say for example, for traffic signal simulation, you change the composition of vehicle, or you change 2 lane to 3 lane. So how it's going to change? Changing certain parameters, how it is going to affect, that you need to study. Collaboration and interdisciplinary approach, so involving multiple experts for comprehensive simulations, because for a city like simulation you need different sort of expertise. Maybe I can give you some sort of expertise in, say for example, in water infrastructure. So somebody is good at doing this for the traffic, so maybe you need a collaboration so that it is the whole system, because one may affect each other in certain conditions. So it can give you a better comprehensive result once you collaborate. Continuous improvement, as because simulation is done on iterative, how you train your model and all. So iterative refinement of models for increased accuracy. So you keep on improving, you train the data. If there is certain glitches, you change certain parameter and all, and finally you come up with something which is reliable. You can also compare with certain past data which is experimented, and then you can validate that okay, even in that particular scenario this result output is something between this range, and our simulation based result is also giving in the same range. Then we can accept that okay, it is performing and it is giving almost a real world uh, findings. Coming to the future trends in simulation research, yes, the artificial intelligence integration to this simulation can make a jump to this advancement. Advancement in AI driven simulation for more accurate prediction. But again, for those cases, you have to train your model. That is something is very important, because all these software application, whenever you give any input, it will give output. But whether it is meaningful or not, the researcher should assure that, ensure that particular output by providing accurate data and also analyzing the output with the realistic scenario. Real-time data utilization using the live data feed for dynamic simulation, which the dashboard kind of thing nowadays is coming into picture. We can also integrate the virtual reality. So virtual reality can help to replicate some of the thing. It can like make things easy for visualize the built environment before actually it is made in the real world. Multidisciplinary integrations, collaborative simulations for holistic planning and design, that is possible through those kind of uh, advanced method where you bring all the expertise together and then do the simulation analysis and come up with some comprehensive and holistic findings. Coming to the summary, here we have discussed about the simulation, which is nothing but creating a realistic scenario artificially, and we test some of the scenario or the conditions which actually not built in real world, but it is generated in a virtual environment. We have discussed about the advantages which can reduce the cost. It can also improve some sort of visualization and all. We also discussed the application in architectural fields like daylighting simulation, thermal comfort analysis, acoustical analysis, etc. In planning also we can use it for disaster mitigation plan, or maybe disaster preparedness plan. You can also use it for certain sort of zoning analysis, network analysis. Along with all these advantages, we have discussed about the challenges, especially the validation part of it, and also the computational requirement, which actually needs a high end computer, which is time consuming and also like the cost. But also with the future trend in simulation, when you integrate VR, when you integrate augmented reality or the artificial intelligence, definitely it can bring certain changes which can improve the simulation platform what is existing, and maybe by integrating you will get certain sort of advancement. With that, I stop here. These are some reading materials you can go through for basic understanding of different research method and the methodology. With that, I stop this lecture and will be moving towards another important topic, which is about the big data. Now, you must have heard about big data analysis and all. So, in architectural planning also there are possibility where we can use the big data. So, handling big data research in architectural planning, will discuss the very basics, because the overall course is for the research methodology. That's why I'm not going into very deep and in-depth discussion on this big data analysis and all, but I'll give you some sort of basic insights into it, which will help, which will actually inspire you to get into those kind of research where you can still utilize, because nowadays data are available, there are certain sort of transformations. So we have those kind of electronic data that are stored and also made available for public. So how we can use it, and we can use it for our planning and architectural research. So we'll be discussing that particular component in our next lecture. So till then, thank you for joining. Bye bye.